Selection sort is sorting an unsorted array into, and we're going to sort it into ascending order. The selection sort finds the smallest element in the array and swaps it with the first element. In this case, the ace is the smallest element in the array, and we're going to swap it with the first element, which is 5. When the first pass is done, we find the next smallest element in the subarray, and which is 2. 2 is already in its position, so we keep it in its place. In the third pass, we find the third smallest element in the array, which is 3 in this case, and we swap it with the third element. So we swap it there. We do that until all the elements in the array are in ascending order. In insertion sort, we are sorting an unsorted array of elements, and I'm going to sort them in ascending order. In insertion sort, we compare the first 2 elements in the array and swap them if the second element is less than the first element. Here, 2 is less than 5, so we will swap them. In the second pass, we look at the next 2 elements, 4 and 5. We see that 4 is less than 5, so we swap them. In the third pass, we see if the next 2 elements are, if we see if A is less than 5, and A is less than 5, the ace, then we also see if the ace is less than 4, which it is, so we swap them. We see if the ace is less than 2, which it is, so the ace goes here. In the fourth pass, we see the 5 and 6. The 6 is greater than 5, so it stays in its place. This continues until all the elements in the array have been sorted. So this one stays. Merge sort is a divide and conquer approach to sorting. First, we divide the array into halves. Then we divide the left half into halves again, and this leftmost into halves. We then look at the first pair and see if the second element is greater than the first. If not, we put them in the right order. So 2 is less than 3, so we will switch them here. We then go to the second pair. 6 is greater than 5, so we keep them in the same positions. Then we will merge these 2 halves together. While we're doing that, we will put them into the right order. We do the same for the right half. And we'll merge these 2 halves together. After the right half, we merge the two halves while sorting the elements into the correct order. There we have sorted all the elements of the array into ascending order. In linear search, we are searching for a key number in an array of unsorted elements. So in this array, my key number I would like to find is 6. So we go through each element and check if the key number is equal to the element. We see in the first element, 5 is not equal to 6, so we go on to the next one. 3 is also not equal to 6, so we go on to the next one. 6 is equal to 6. Since we have found an element that is equal to the key number, we will then return the index of the element, which in this case would be 2. For binary search, we have a sorted array of elements. We are also trying to find the element equal to the key number. I would like to find the key number of 2 in this array. So in binary search, we first look at we labeled the last element as high and the first element as low. We then would like to find the middle element. To find the middle element, we take the index of the first, the low number, and we take the index of the high number, and we divide it by 2, which in this case, using integer division, would be 3. 4 is our middle number in this case. We see that 4 is not equal to 2. In fact, 4 is greater than 2. Since we know that 4 is greater than 2, we know that the key number would be on this half of the array. So with that knowledge, we change the high index to the element before the previous middle element. Then using the same procedure, we find the middle element of between the low and high, which would be 2. We see that 2 is equal to 2, so we return the index of this element 2, which is 1.